The streets are now being populated, not just with lamps, but with cars. And we now have trees filling out a lot of the little blank areas here. So we have something going on when there's not a house or just something in the general vicinity. So now we have nice lamps that all face towards the road. The cars all face in their respective directions. And that's what we're going to be going over in today's tutorial. Yay! Unfortunately, it is not moving cars. Yet. I say yet because I am hoping to look into how to actually set up proper traffic in the future. I don't know when that will be, but that is on my list. I definitely want to do that. As you can imagine, that probably is not the simplest thing to do, but we'll figure it out together. For now, though, we'll make it at least a little bit more aesthetic. Start putting some greenery in. I'll show you how to populate things on the sides of the roads, make sure they face the correct way, and start populating cars to at least appear like they're on the road. Now, while I am going to be building it on top of my current city gen, whenever I attach it somewhere, I'll let you know what you need to put in there. So that way, whatever your setup is, whether you're using it for a city or something else, you'll know how to kind of incorporate the same setup into yours. So you know what from your setup plug in and where. So let's get started. Now, in my case, I will be using both PCG and PCGEx nodes. Under Edit Plugins, you search for PCG and make sure you have PCGEx in Toolkit and PCG and PCG Geometry Script Interrupt all enabled. We're going to be making use of all of this. Assuming all this is enabled, you're good to go. And we can get started with setting it up for this pretty barren city. You can see how much difference having that extra vegetation, streetlights, and cars did. Because now it's okay, but the difference between having something and nothing is quite drastic. We'll get started with the trees. Then we'll populate the lamps, and lastly, the cars. If I come over here to this area where we've split the main paths into two different directions, now let's use a simple debug here so we can take a look, and we'll just set it to be absolute. You can see we have these points out here, which we're kind of using to basically populate the buildings. But this is good. We can use these points or wherever you kind of want to spawn these along and basically say, hey, can we spawn trees in these locations? And if we're going to intersect with a building, then obviously don't spawn anything there. What we're going to do is, instead of having one point here, I'm going to take a create points grid, copy it to each of these points, randomize it a little bit, remove any overlaps, and then what we'll be basically left with is effectively some random patches of trees. So let me show you how that's set up. As I said, these are the main points that we're using. Of course, wherever you'd like to spawn your stuff, just go ahead and use those points here. But we'll just be using a copy points node. So this is our target points. And what we're copying to that is just a create points grid node. The create points grid goes to copy points source, and I'm leaving it on just default. You can adjust how many points, how far, etc. You can make it local, you can make it original component. This one doesn't matter because we're just copying the points directly. So by just doing this, I can debug this. And you can see now all of those single points effectively are grids of points. Now they're very close together, so you can't even see that it's a grid. But if I change the extents to absolute of like 0.1, you can see now we are getting a little bit of variation here. So there we go. That is a good start. We now have this kind of thicker grid here. Now we don't want to have that many points. So let's go use something like a select points node. Let's go ahead and keep 10%. I'm going to then merge all the points together. So instead of them all being different data sets, since they're coming from separate splines here as the targets, I'm making them all together as one big set. And then we can randomize the position. Use a transform points node. I'm going to move them randomly between negative 500 in X and Y to positive 500 in X and Y. I want them randomly rotating between 0 and 360 degrees in Z. And I also want them to randomly scale between 1 and 1.5. So we have some variation in size. If I go ahead and debug this, that is looking pretty good. Okay, that's working well. We now have a lot of randomness here. So excellent. We probably have too many points still. So maybe we'll tone it down to something like 0.05. So tone it down maybe by half. We can play around with this value. In fact, we can just convert this ratio of select points to a parameter by adding a new float, pressing F2 to rename it. I'll call this tree ratio, and I'll make it 0.1 by default. I'll go ahead and grab it, drag it out, and plug that into the ratio of select points. So now we can control this dynamically. We're also going to need to populate the trees. So while we're here in the parameters, let's go ahead and make a new variable here. I'll hit the capsule here, and I want to change this to a static mesh because I want to spawn static mesh object references. I'm just going to press F2 to rename this to trees so that we can populate the trees, and we'll hit the little caret down arrow here, and we'll change it from single here to an array. So we can have an array of different trees and we'll automatically populate this. I'll go ahead and populate all of these with just the default PCG trees. Grab PCG tree 1, 2, and 3 tree and populate them here. So we have a bit of variation in the trees. It's okay. This is working. Awesome. Now we can go ahead and assign these trees to the points. So I just click and drag and bring this over into our graph. So the way we randomly assigned one of these random trees from the array to the points is by using a match and set attributes node. Match and set attributes basically will assign one of these random things from the array to these points. So if I select match and set attributes and press A, and I just scroll to the right, you'll see there's trees. You can see there's 2, 3, 1. So you can see now they're being assigned randomly to these points. Some of them have 1, 2, and 3. Perfect. So already we can kind of take a look at it by using a static mesh spawner. We just need to change it to selector by attribute for the mesh selector type. And the attribute is trees, because that's what it's called right here. Call this trees. And already we can see, yeah, that's a lot of trees. Probably too many trees, honestly. So a couple of things we can adjust here. I see that there are places where we still have a bit of gaps in places. So maybe we want to have a little more movement of them. So the transform points, I'll do minus 1,000, and 1,000, 1,000. So now it kind of goes out a little bit further. I kind of like that more. Now, what we're getting occasionally, and it's hard to see, is that the trees are moving in sync. Because occasionally some of these actual points have the exact same seeds. So they will move exactly the same as another one next to it. So you'll get trees right next to each other moving exactly. We want to randomize this. So it's actually every single tree has its own random seed. We need to do that before the transform points. We can do that very easily by just adding a mutate seed option. So we'll just do mutate seed and we'll randomize the seed for all of the points. And then the transform points will use that. I have found that recompute seed doesn't always get the same result as mutate seed. In this scenario, mutate seed did work where recompute seed on the transform point did not. So for example, this is without it. And you can see right here, especially on this curved road, you see how this is the exact same tree copied over and over and over at exactly the same rotation, exactly the same everything. And if I go ahead and enable it, now we actually have actual randomness. Okay, so this is good. One thing we are noticing is there's way too many trees, of course. That's why we expose this tree ratio. So I'll go ahead and set this 0.05. Let's cull out quite a few of them. And we also don't need to remove anywhere where there's a building because we can't see our buildings, and that's kind of important. Now I'll go ahead and remove this right before the static mesh spawner because we definitely want to do it after the transform points. Before the static mesh spawner, I'll go ahead and just drag out and grab myself a difference node, and I'll make the difference be set to binary, and that's going to go into the static mesh spawner. And the thing that I want to cut out is the buildings. So I'm actually just going to grab this static mesh spawner from my buildings. I'm going to plug that into the differences node. So in your case, wherever grav you have set up, whatever you want it not overlapping, just plug that into the differences and you should be good to go. If we take a look now, okay, so now we're getting better. Okay, you can see it is now substantially better, and it's actually even more trees than you saw during the old preview. We just adjusted some things. Now, a couple of things that are a problem here, and that is that we have trees in the roads. I have exceeded the actual offset now, and so we're now getting trees in the roads, and we probably do not want that. There's a few ways of getting rid of these trees on the roads. We can sample the road, the actual splines, and give it a thickness, and then remove points along that. That's probably gonna be the easiest way because these are spline meshes, so unfortunately we cannot just sample them like we did the static mesh spawners. Because they're curved, there's no real bounding box we can grab. But if we look at the original spline that were created and sample the bounds modifier when we just made it a little bit bigger to visibility, you can see here, okay, that is the road, and it's a little bit narrow, but otherwise it's actually pretty good. So we can actually probably just use this. Now I want to use this probably in a few areas. So what I'm going to do is I'm going to add a new named reroute declaration node. So I'm going to drag out and search for name, and I'll add a named reroute declaration node here on the bottom. I'll press F2 to rename it. I'll just call it something like sampled road splines. And then I'll go ahead and plug those all the way through. So we have back to where we were. But now we can grab this sampled road splines and come over here to the difference node before the static mesh spawner. We'll go ahead and grab the sampled road splines, but we want to use a bounds modifier here. Because again, the bounds that we had before were just not big enough. Again, if I press D to debug the bounds modifier, default settings, it's just a bit narrow, right? So we could try by first scaling everything by 2. We'll just scale everything on this bounds modifier by 2, bounds min and bounds max. And you can see, okay, that is pretty good. I'd say it can go even bigger though, considering the size of the road. I'll say maybe 2.5. And 2.5 is pretty much exactly where we need to be for this road. Now you can go a bit bigger. That would be also fine. But for what we're doing, I think 2.5 is just okay. And now we can just go ahead and take this bounds modifier and plug that into the differences as well. And you'll see that it has removed all of the trees that were kind of in the way, but we've kept some right here in these locations. Now you might be looking at this and thinking, oh, it's removed the streets, little driveways. No. Those are for the other side. You can see right here, it is still keeping all the driveways, but it is still intersecting with the driveways. We don't want it intersecting with the driveways. So let's go ahead and make sure that for places where it intersects with driveways, it is also removed. Now in my case, the driveways are all the way at the end here. If I have the static mesh spawner and sample it, you can see, yep, there's the actual full width of this driveway. And I just use that as a difference node. I don't want them anywhere close to these, so we can just go ahead and use that. Let's go ahead and try it out. I'll go ahead and add another named reroute declaration node, and this is going to be our driveways. So over here, I'll grab driveways and plug that in. And if you take a look at this building right here, I can go ahead and turn it off and turn it on, and you can see it goes ahead and removes the tree that is kind of in the way of this driveway. Perfect. We still have some on the sides and between, but it just removed them kind of in areas where it would intersect with driveways, with the road. And now we have a lot more foliage even than the preview that I showed earlier. So I've gone ahead and extended it even further. So you can see here, it is now quite dense, and it might be too dense. You might want to have it be a little bit less. We can go ahead and populate to 0.03. But one of the things that will actually help with this is pruning a lot of the self-intersecting ones. So let's go ahead and keep it back on 0.05. And if we go ahead and just fly in, you'll see a lot of times, if I go to unlit, they're just touching a little bit too closely here. If I just sample this transform points all the way back here, before the match and set attributes and before the differences, you'll see there's our actual points. And you know what? They're a bit bigger than the tree stumps, but honestly, I think that's fine. I could sample the bounds of the trees, but that would be very big. I only care about kind of the trunk area. And honestly, this area is fine. So what I'm going to do is I'm going to tell it to not have these intersections by using a self-pruning node. So after the transform points, we can use a self-pruning node and plug that through. And instead of large to small, I'm just going to say all equal. It doesn't matter. Just randomly prune them. And now if we take a look, it is now a little bit better. It's not as dense. So this is on and this is off. You can see it is getting rid of a few of these points. So just really the ones that are kind of really overlapping. And if you really want to kind of have them not be even this close, before the self-pruning, you can add a bounds modifier here. And I can scale the bounds, let's say by 2. So if I was to debug the bounds here, you'll see they're actually a bit bigger. That also will help prevent it from being as close to the driveways if you want, or as close to the road. So now with having it at 2, you can see there's a bit fewer trees. If I go ahead and disable the bounds modifier and enable it, you can see that's what we're losing. So we're losing quite a bit of trees in some places. Maybe you kind of want to go in between. You can play around with it, say 1.5, and this is nothing, 1.5, nothing, 1.5. You can see right here on this building, without it, we keep this tree here. And of course, with the bounce modifier 1.5, we do lose it. So it all depends on kind of how you want it to be. I kind of like the more, so I'm going to actually remove the bounce modifier for myself. I'll keep it nice and lush here. And this is working quite nicely. So with this in, now let's go ahead and add the street lamps that we want to kind of populate on the sides of the roads. For street lights, it's going to be actually a very similar setup, but we're not going to be copying the points or things of that. We're going to basically take what we have, duplicate the setup, and offset the points different amounts. So instead of going all the way like we do for the buildings by offsetting from the road so far, we're going to go a little bit closer to the road so we get it kind of on the width of the road. And that way we get the lampposts facing correctly. And then we'll need to make sure that they're always facing into the road and not some random direction. Sort of like what we did with the actual buildings, which is going to look quite similar. So I'll come down over here and I'll grab the sampled road splines, and then I'll search for offset, and I'll do the clipper to offset node. And for this offset, I'm going to offset it by 460, which I found is a good spot for my road. At the current moment, right, we're all using the same road size for everything. So I can just kind of hard code this. Later on, when we figure out a good way of doing multiple road sizes, it will just auto-populate it, which is why I'm not really going to expose this value. There's really no need. So I'll keep it on round. And if I go ahead and just debug this point now, we can take a look and you can see basically on the outskirts of all of these roads and at the end here, we have this kind of dead end. Now, it seems like the round one, while nice, is way too far out. You can see here, and the other dead end is just going way too far. So I will go ahead and change it to but, which does have it go out a little bit further still, but it's not rounding all the way at the end. I'm kind of okay with this. We can always remove the extra points here. That's not a problem. So when we have the offset now, we can use another PCGEx node called path resample. So this is kind of the distance. At what distance do you want these points to actually exist? The resolution by default is 100. We'll set it to be something like 800. If I go ahead and debug this, you can see now we have the points 800 away from each other. So this is kind of where the lampposts are going to be. You can adjust this accordingly. We probably should expose this value though. So add a new parameter here. I'll default it to 1000. It's a nice round number. I'll go ahead and grab it, open up this resample and plug that into the constant. And you'll know that this is the correct one because under resolution here, it's now grayed out. I can't type a value in here anymore, which is how I know this is the right input. So again, if I sample the resample node here, let me take a look. We're going to run into a few things, namely with the driveways again. Now, I do want to have them be closer to this driveway compared to the trees. I'm okay with the lamppost being right here, at least personally. If you want, you can have it not be that close, but I'm kind of okay with it. But to do that, it needs to be a little bit tweaked in terms of the bounds that we're currently using for these points and the bounds from the driveway. Let me explain what I mean. Basically, if I use a difference node right now, and then again, set it to binary, and then we grab the driveways and plug that in and debug this difference node, you will see the points are gone. But the thing is, if I go ahead and disable a difference node, this point is gone too. And so is this one, but they're not touching the driveways at all. So that is odd. Why is that point disappearing? And that's really to do with the fact that the difference isn't that exact. And that's really the thing. I played around with some values and I found ones that kind of work for what I think is the goal of this. So what I'm going to do is I'm going to change the bounds of the points of these lampposts. So I'm going to use a bounds modifier right before the difference node. And on this bounds modifier, instead of scale, I'm going to set them to be minus 50 in XYZ to 50 in XYZ. So if I debug it now, you'll see they're now quite a bit smaller. The main post of the lamppost is small, so we don't need to make it super big. By making these smaller, you can see even when they're relatively close to the driveway, you still have these points available. And I haven't found any scenario where they kind of disappear where you think they should keep, except right here. If you look right here, you see no points, but if I disable the difference node, this point has disappeared. And you can see here, I'm debugging the difference node just from the driveways, cutting it out, and it is removing effectively a bit too far. Despite it not being touching at all, it is being removed. And I'd like to keep that point. So in order to keep it, we just need to modify now the bounds of the driveway. So after the driveways, we'll use a bounds modifier here as well. We plug that into the differences. And all I'm going to do is I'm going to shrink in Y. Y in our case is the thickness of it. X is the length of the driveway, width is Y, and Z is height. So I have found that 0.6 works really well. Of course, if you have different driveway sizes, this might need to be adjusted for you. But you can see now, with it still enabled, we keep this point. So we effectively keep this light of the driveway, which is great. Now, if we take a look, some of these points are just not in a good spot. And that's mostly because we're using the points from the original location before we kind of did our little offsets and things of that nature. So it's not ideal. What we can do instead is use them from the very end when we actually have made all of these changes and then use these points. I'm talking in our case at the very end when we're doing this spawn spline mesh, because this is after the tangents. We can go ahead and sample these transform points, for example. Although these are very big, let's go ahead and sample the ones right before that in this rotation to tangent. And you can see, yeah, those are the points that are a little bit better here. Now, I would like to actually keep them all the way through with the create spline because it does apply these tangents that we calculate here. So really, I want to grab it from here. So what I'm going to do is just drag out and add another named reroute declaration node. I'll call this road splines with intersections. So we'll go ahead and use those all the way down here. I'll grab the road splines with intersections and we just sample them. So we'll use a spline sampler. In my case, I just want to sample kind of what they are. I don't really need to do anything. I just need them to be points. So I'm going to keep it on spline subdivision per segment. I'll just set it to be 0 subdivisions. Give me the original points. Instead of the sampled road splines, we now are going to use the spline sampler. And again, if I sample the differences all the way down here, you'll notice something odd. We now have very large points here and very large points in general. Well, that's not right. Basically, these points were originally scaled. And so the difference is using that scale accordingly. So all we need to do is right before the bounds modifier, after this resample, we'll do an apply scale to bounds. So if it has the 10x scale that we were using, it is now just going to apply them to the bounds, which doesn't really matter because immediately after on this bounds modifier, as you recall, we're just setting the bounds to be this size. So now with this setup, you could see that it is now following the contour here a lot better, isn't it? Now we do have some points on the road now, but we've dealt with this before. We can get rid of them again. So we just need to clean up these few few stragglers that are kind of in the middle of the road. Otherwise, they're following pretty well on the outskirts here. So just like for the trees, I just need to take my sampled road splines, the bounds modifier. I'll copy it down here. The difference is we don't want it to go as far. So right now we have a 2.5 and 2.5 is the full width, but we're trying to spawn them on here. So really for us, maybe like 1.8. Maybe we'll go, if I set all of them to 1.8, it's slightly inwards, and that seems pretty good. So we'll go ahead and just use that and plug that into the differences, and again, sample the difference node. And you can see now we're just left with the ones kind of at the edge here, and we've removed the ones that were kind of in the intersections causing issues. So awesome, this is going pretty well. Next thing is we want to spawn things. So let's do the same thing we did like for the trees, add a new variable. We'll change this to be a static mesh object reference, rename this to light posts. I'll make it an array. I'll go ahead and add a default one here, a light curve. You can add multiple, so that way if you want to have it randomized, but in my case, I'm fine with having just one. And again, match and set attributes. And right here, you can see when we try to do it from this spatial data, it's giving us this odd conversion. So instead, to fix that from the difference, we're going to search for 2 point. We have spatial 2 point here. And now this point data, we can send to the match and set attributes like we have before, and light posts will go into the match data. Then a simple static mesh spawner, again, by attributes. And this time we called it light posts. So for the attribute name, call it light posts, and we'll see that they are absolutely tiny. Why? We set the points to be 10 times smaller, if you recall. So we need to rescale them back up. Right here, we did apply scale to bounds. So we lost the 10x multiplier that we needed because of Kenny's assets being a bit small. So we need a new transform points node. And then we can just go ahead and scale them once again from 10 to 10 in scale minimax right before the static mesh spawner. And now we're getting in a pretty good spot, but you could see what's happening. They're not facing towards the road correctly. Okay, so we're getting to be a better place though. So now let's go ahead and make sure they always face in towards the road. We'll do that right before the transform points node. It doesn't really matter. You can do it after as well. But I found that we need to face them towards things, so we can just grab the same setup we had before, which was the PCGEx sample nearest point. But our setup is going to be a little bit different, so we'll go ahead and recreate it from scratch. And I'll show you in case you haven't seen it before as well. So from the match and set attributes, we'll just search for nearest point. So you want a PCGEx sample nearest point, and that's going to go right before the transform points. And we have this road spline with intersection set up here, so we can go ahead and use it. I'll right click, search for road splines with intersection. We'll just use a spline sampler here, and this time I want to sample it by distance. Instead of subdivision, we'll change to distance, and 100 is fine. If I go ahead and debug this, you will see there's quite a few points, kind of hard to see, so let me just change the scale method from extents to absolute, and you'll see there's quite a few points, and ignoring the intersections. And considering we're trying to face these towards the road, I don't really want them facing diagonally anyway, so this should be okay. So now I'll take this spline sampler and plug that into the targets. We just need to configure now this sample nearest point. Under sampling here, instead of all within range, I just want the closest target, whatever is the closest point. And instead of within 300, I want it to be within 3000. So I want whatever is the closest within 3000. That is way more than enough range, but it's only getting the closest one anyway. So as long as the closest one is always within a certain range, you can make this smaller. Theoretically, when we increase the size of the roads, we probably will need a little more room. So that's just a safety net. And then under the sampling, we have apply sampling. So we just open it up and turn on apply look at. Very important. And then we also want to turn on Z. I wanted to rotate along the Z axis to look at these points. Now it's almost correct, it's just not oriented correctly because the meshes are not X forward, they're Y forward. We could adjust it on this transform points by rotating 90 degrees, but instead on the nearest point, I just open the outputs here. And instead of align forward, I'll set align left in my case. And when I do that, you'll see there's all the lamps kind of facing inwards. So that's pretty good. And you can see here, this one is a little bit on the inside here. So maybe you want to adjust this bounds modifier instead of 1.8. I just adjust it to be 1.85. And you can see that problematic one is gone, but we've still retained pretty much the ones on the outside. Excellent. So this is working really well. We now have our lamps and they're all facing inwards. And you can see even right here where we have two right next to each other, they're still facing towards the correct one that they should be relative to where they were placed. So the lamps are working well. The one thing to note though is I'm not checking that they don't intersect the trees. And you might want to have them remove trees that are right next to them. If you want to do that, you could take the static mesh spawner and again, add another named reroute declaration node. We can name this to be light post meshes. And then add the trees, just like we cut out the driveways and the road splines, we'll cut out also the light post meshes and put that into the differences as well. And pretty much it will not remove almost any tree trees, except ones like this where it's clearly way too close. Again, I'll replug it in on my end and you'll see this one disappears. And there was another one that disappeared next to it. Again, this is just for the ones that are purely touching the light posts, so that way we don't have any issues. Now, as I've been flying around looking at these lampposts, they all look pretty good, but I did find one small problem, and that's to do with the T intersections. You see this light right here, because we're sampling and telling it to look at only the points that are not part of the intersection, on specific T intersections, this causes slight issues. We can kind of get around this by changing what we're looking at. Right now, we're looking at the final ones that have the intersections built into them. So they're the kind of the cut roads that have been realigned, really. So instead of this, I want to sample it towards the original roads here. So I'm actually going to copy this spline road data and the spline sampler. I'm going to paste it over here and replace this with this guy. The difference is on the spline sampler, instead of 500, I'm going to say this 100, and I'm going to tell it to have that be the target. And you can see this one now is a little bit better. The position of these is not perfect, I will say, and that's all mostly to do with the fact that these intersections kind of get warped and realigned. So here we do have a little bit of slight variation in how they kind of line up. There's also a very thin sidewalk that you'd have considerably thicker normally. So given that you could have a thicker sidewalk, this wouldn't even be an issue when it goes a little bit further out. So I'm saying this is fine. And you can see here now they're facing the correct way, no matter which one. The last one to do is the cars. Cars we're going to do a slightly differently, but a lot of the same. The main thing for the cars is I'm going to be using the main original roads, not the ones that were slightly offset to fit with the intersection. The reason I'm using the original ones is one, the intersection change isn't insane. It's mostly still the same. And two, cars don't typically follow exactly in the middle of the lane anyway. They usually have a little bit of sway, and we're going to add some visually to also help with that. So the fact that they're not going to be perfect, I think, is, if anything, more character. You could also look at that as an excuse. I'm okay with that. So for the cars, I'm actually going to take the original spline data and again, spline sampler. I'm going to copy it down here because what I'm going to do on the spline sampler is I'm going to change the distance increment to be 425. Now, why 425? This is the distance of the cars when they're right next to each other with a little bit of extra, just a little bit of breathing room so they can move a little bit forward and back, which we'll add in a little bit. So if your cars have 400 or let's say 375, you just add a little bit on top of that, and that is actually your kind of spacing between them. This way, when you spawn these cars along the spline, they will not be actually intersecting each other, which would be dangerous, at least for the driver. So just like the other one, we need to offset it. So we'll use the Clipper 2 offset. The offset amount will be 150 and the end type will be but. So if I go ahead and debug this and then scroll down and change it to be absolute debug, you can see there's all of our points. And you can see even the ones that are technically a little bit warped from the intersections, you cannot tell. They look like they're in the middle of the intersection. And again, right, this one's clearly in the middle. This one's a little more to one side because you can see here it's kind of warped a little so that way it can fit and attach. Not a big deal. Same thing here. So I'm saying that this is going to be fine. Don't worry about the points in the intersections. We're going to be removing those. The main thing is the road ones, I think, are going to be just fine. So we need to get rid of the intersections. So let's use a difference node. We'll set it to be binary, of course. And all we need to do is use the intersection points that we created before. These intersection points, if you recall, are right here. Once we did the spline intersections and we grabbed the dead ends and we merged them all together, that's our intersection points. So our intersection points are going to be what we're cutting out, but I just want to use a bounds modifier because I want to make sure that it is the size of the intersections. So instead of scale, I'm going to do a set. I'm going to set them to be negative 350 in X, Y, and Z to 350 in X, Y, and Z. If I go ahead and debug this after, you can see there's our point right there, and that is honestly good enough for us. The main thing is we want to make sure that we don't have any cars spawning in these locations. You can see even at the end here, it is removing all the ones back there. T intersections and everything now has this nice large square. We can make it a little bit bigger, but I'm fine with a car being right here, right up to this kind of crosswalk. So that's fine. Let's go ahead and plug that into the differences. So now if we sample the difference node and we change it to absolute, you can see now we're getting kind of more of what I'd want, which is just straight points all over along the splines, going along everything. That looks pretty good. So let's go go ahead and start spawning the cars and see what it looks like. I'll drag out and do a 2-point node. So we convert from the spatial to points again. And then I can do a match and set attributes. And we need to then go into the graph parameters, add ourselves a new parameter, change this to a static mesh object reference like before, rename this to, let's say, cars, and of course, change it to an array and start adding all our cars in. In my case, I have a bunch of cars from Kenny again. I'll make sure to link Kenny's page where I got these. All I did was take them and make them one piece because they come in as bodies separate from wheels, separate from doors or stuff like that. I just put them all together into one mesh and just saved it back out. And that's what I'm using for the different cars. Once we have that, just go ahead and grab it, drag it out, and plug that into the match data. And then we can use a static mesh spawner, and we'll change that, of course, to an attribute. And this attribute is called cars, because again, that's what we call the cars here. So we take a look, you can see there's our cars, but they're not facing the right way at all. They're all facing sideways in the same direction. I want it to face forward in one and reverse in the other. Thankfully, because we use the PCGEx node, this offset, that is kind of what we can get with it automatically. All we need to do is after this offset node, we can grab a path orient node. Now, it's called path orient, even though it says look at above. So unfortunately, like you can see here, clipper to offset, if you search clipper to offset, you get it. But you cannot search look at, despite it saying look at top. Unfortunately, you have to search for path orient. Just a heads up, path orient is look at. Maybe down the line, he'll add that search function. I don't know. But we just have this look at right before the difference. And now we can see, okay, well, it sort of did something. We have issues also. We have a few points that are right on top of each other. Yeah, that's some problems here, So what I'm going to do is after this offset, I'm going to do a collapse points node. This is just in hopes of getting rid of those extra overlapping points. And then I'll plug that into the look at. So that overlapping one disappeared. Okay, so that's good, but they're still not facing the right way. And really, they're not facing the right way by 90 degrees. So now all we need to do is right before the static mesh spawner at a transform points node, and I'm rotating them by negative 90 degrees in Z only. So negative 90 in min, negative 90 in max for Z. And you will see that there we go. They're now facing the correct way for the right lane and correct way for the left lane. You can see they're all following across, and yeah, that's pretty good. But they're right now perfectly in the middle of the lane and perfectly spaced. So let's also add a little bit of variation here. I'll say minus 20 to positive 20 on the offset in X. X is the forward and back along the road. So they come a little bit closer and further apart, bumper to bumper. And I'll say minus 30 to plus 30 on Y, which moves them side to side to give them a little more natural variation there. So you can see now they're no longer perfectly in the middle, and we have a bit of variation here, which makes the parts where, again, the intersections kind of warp to fit the original like snapping points not really matter. You can't tell that, oh, they're not in the lane, because they are. Even despite everything, even though the lanes are kind of coming together, yes, they're closer to this side here, but they're still in the lane, so I think that's still fine. Now, we don't need this many cars. This is gridlock traffic if I've ever seen it. So after the look at, I'm going to add a prune here. So I'm going to do a select points node right after the look at. I don't want to do it before because I want to make sure they're looking at their correct locations first. Then select a random amount of points, and I'll go ahead and open this because I'm going to add a new parameter, and this is going to be cars ratio. I'll say 0.5 as the default, and then I'll plug in that ratio in here. And now we have it pretty well ratioed. There's gaps, but you might notice we have exactly left and right always together. And not only that, they're always the same car. That's because they're based off the same original point, and when they got split, the seed of the point is exactly the same. So we need to randomize that point's seed for each one. So after the collapse points, just drag this over and just do a mutate seed. This will randomize it for every single point. And now you can see, now we have different cars and all randomized between left and right lanes. This is 50% across the entire place. We can of course control that now, so we can have more or less cars if we so wish, depending on the kind of areas you have or want. And by the way, I have not scaled these cars 10x like I had to for the other things. The main reason why is because I didn't need to. The cars are the correct size, while the buildings and the roads came in and at 1/10 scale. So obviously for your setup, scale or don't scale accordingly, depending on the meshes you're using. And then with a little bit of shallow depth of field, we can actually make this place look like a large miniature set. And we have now nice lamps going along the streets, cars, buildings, and trees everywhere. So it's starting to feel actually and look like, instead of just some random buildings along some roads, an actual city, which is pretty awesome. Of course, this doesn't make a city yet. There's still so much to do, but it's finally feeling like an actual city, at least visually. Now, as always, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. If you'd like to join the community, link to the Discord will be down in the description below, as always. And let me know what you want to see for the next part. Again, there's so much still to do. I'm curious to know where you want to start taking this series. If you're looking for something else, a little non-city-esque, I recommend you this tutorial right over here to learn what else Unreal Engine has to offer.